Welcome to generics. Now, I want to take you through a three-part process here of generics. The first part of generics I want you to understand is that some classes you will be able to reuse a variable over and over again, but sometimes you don't want to create different classes to use it. And this is where some of these variables are generic. Sometimes they could be integers, sometimes they could be doubles, sometimes they could be floats or strings, but they all being handled the same way. And if they're all being handled the same way, there's no need to actually create a different class each time to handle it. What you could do is just create a class with a generic data type that you could use throughout your code. Here's an example of one right here. This is a regular class, and I have an integer and a double. But I also have a data type called t right there. And we don't know what t is yet, but we know we're going to be able to handle t no matter what it is. If it's an integer, a double, or a float, or a string, we want to be able to handle it the same way each time. So I will go ahead and give this class a parameter up here, and I would put a t in there. And you could use any letter you want. Capital letters are by convention what we use. And what t means here, like stands for template really. You could use any letter you want, but t represents a data type that you will be replacing t with later on in the code. As you notice that, okay, so I created a generic data type called t. I'm going to have a data type called t. The variable name gen is going to represent the variable name of type t. This method right here takes in a t kind of variable, and this one returns a t type variable. Alright, so if we go to our test class right here, you notice that I have two sets of classes, generic class 1 and generic class 2. And what I'm going to do right there is I have a generic class, and I replace the t with integer right there. And I replaced this t right there with integer. So when I call the constructor, I have integer there. Okay? So, and when I do that, if you go over to class, you'll notice that this t right here will change into integer. So everywhere you see a t, which is right here, or right there, that should look like integer when you call the constructor and create it. So let's go back to the class. You'll notice that I put in an integer here. If I were to put in, say, a string of some sort, it will give me an error. Okay, it only will allow you to take in an integer for method set, because that is what set is right here. Okay, so, and when I print this out, I should have a there we go. When I print this out, I will just get the 5 right here. So we can go ahead and demonstrate that really quickly. And you do get the number 5. Now, if I create another one, and this time, this generic class that I made with, I'm going to add in a string to replace t. So string is going to be replacing t all through the code here. And if I run it, it'll say my string. So both of these classes have the same, are of the same type of generic class. I didn't have to change the variables over again or add new methods. I use the same methods in the same variable for the integer and the string. Because it was generic, I was able to replace it when I called the constructor, which made it more powerful and easier to use. So anytime you have a concept of when you want to create a variable that is generic, could be any data type you like, because it's handled the same way, this is the way you would do it and test. Now to make something a little bit more easier to follow, we'll actually try to do the lower and upper bound, which is the other two parts that I was talking about. So let's take a look at that. So let's take a look at that in the lower bound area and the upper bound area of generics. So this is an array list. I have 3 of them created for you. Now you're familiar with this. These are also generics, if you didn't realize it. An array list with the integer, string, and number in them. You could have a generic array list. Gen list gets new array list. And if you had that there, you could actually simply myGenList dot add 7 and myGenList dot add Scooby. And this generic list actually, right here with no parameters, will actually take in 7 and Scooby right there. And if I were to print this out, genList.toString, then when we run it, then when we run it down here, you could see that it printed 7 and my Scooby. So this is a generic array list. It takes in anything you want. It doesn't have to be parameterized right there for specifics. It takes in anything you like. Now, right below it, we did define this array list to take in certain parameters. This one is an integer, this one's string, this one's a number. Okay? I simply named them my list, my string list, and my num list. Now, right below it, right here, you see that I added 23 to the integer list and 47 to the number list. I created a variable called sum, and sum's going to call upper my list. Now this is going to demonstrate the upper bound right here. Now what the upper bound means is that you have this little funky code here. What this means is it's going to take in an array list called AL, and this particular array list has to be an array list that anything, that's what the question mark means, wildcard means anything that extends number. So numbers on top of the chain, that's why it's the upper bound, that's the highest point, number. So anything that extends number, which means anything down the chain from number, could be accepted into this method. Okay, so what extends number? Well, integer extends number, so does double, so does float. So basically anything that has an array list that extends number, like double, float, or integer, or number itself, could be accepted into this method. And as you can see, I'm passing in as a parameter my list. My list is integer. Integer extends number, so therefore it will be accepted in here. You see there's no red lines here. And once it's accepted, I'm going to get the first value and then just return the double value of it and assign it to my double and return a double. And it's going to print out 23.0, which is what was added to that list there. So that's pretty good, but you notice that if I take the comments out here, I'll get a red line for the string one, because string does not extend number. String does not extend numbers, therefore it could not be used in this particular method. So why is this useful? Well, what if you had to use this method over and over again, and instead of method overloading, creating 3 separate methods, one that accepted integers, one that accepted floats, and one that accepted doubles, and maybe even a 4th one that accepted number, then you would have to make 4 methods. Here you could just use one method with a wildcard, anything that extends number, and all 4 of them could be passed into this one method. So that becomes very useful. Now, right along from that, we have something called a lower bound, and instead of this being the highest point, this part is going to be the lowest point. And you notice we use the keyword super, so anything that is the parent of integer. So it could be either array list that is an integer array list, or a parent of integer, which could be number. So number and integer could be, in our example here, the ones that can be passed into this array list right here. Can double be accepted? No, it cannot, because it's only the parent of integer right here. This is what represents the lower bound. So we take in a list, and you'll notice that my list is an integer list, so therefore it could be accepted. And it'll also take in a my num list, which is a number. That is the parent of integer, so therefore it could also take that. The string one will give you an error because it is not the parent of integer, or one of the parents. So this lower bound sets the minimum point, and anything above it on the hierarchy chain is what it's going to accept. This right here for the upper bound sets the top part, and anything below it will be accepted in the hierarchy chain. And right here I just added some random digits here inside of the list and then printed it out. As you can see, when my list was added to 23, which is what we added up here, and a 47 for the num list, it just added 0, 1, 2, 3, 4, 5, and the same down here, just to demonstrate that it works. Okay, hopefully this was helpful in better understanding generics. I will see you in the next video.